All right, College Algebra B. I want to give you some feedback on your 4.1 and 4.2 quiz. We have a Chapter 4 test on Wednesday, and many of these questions will come back up. So if I start with this question, it says, if you borrow 5,000 at a rate of 7% interest, compounded monthly, how much will be due in 5 years? So there is a formula that tells me the amount I owe is my initial amount times 1 plus the interest rate over the number of compounds per year to the power of nt. And so to recognize I have $5,000 as my initial value, then the rate is given to me as a percent, which needs to be changed to a decimal. And it tells me compounded monthly, so that's 12 times per year, and then 12 times the initial times the time invested, so 5. And so a challenge is being able to type this in your calculator in one fell swoop. And if you have a 2-line calculator, this works just as easy. If a 1-line calculator is all you have, then it's a little bit cumbersome to work with. But let me show you a workaround here after I type this. I'll go ahead and do the 12 times 5, which is 60. So that tells me that I'm going to have $7,088.13 as my final payoff amount. A lot of times these calculations can be done at Desmos.com. I know I'm a huge fan of this website, and we typically would go here to graph functions, but it really works well just as a one-line graphing or scientific calculator. So if I just type this in the way we had before, I will get the same answer. So let me just show you how fluid this goes. I'll use the caret key to access the exponent, and then that's to the power of 60, I get the same answer. So don't forget that Desmos.com works really well as a calculator as well. Okay, the next question looks like this. You earned 2.25 annual interest rate compounded quarterly on money you invested. After 10 years, you now have 2,000. So how this works is we have the same formula, and we're going to not solve for A, but we're going to solve for P. We have $2,000 at the end of 5 years. So if I plug in my interest rate of 0.225 over the number of times compounded per year, which is 4, and then to the power of 4, and the amount of time we said was 10, then the idea then is I want to simplify what's being multiplied by P. So a quick way to do that is parentheses 1 plus 0.0225 divided by 4. And then to the power of 4 times 10 is 40 times it's going to be compounded. And so that gives me 2,000 is the same as P times 1.252. So now we've turned it into a one-step equation, right? So if I take 2,000 and divide it by 1.252, I'll get the amount of money I invested, which is just almost $1,600. So this next question is a change of gears because it has the word continuous. Anytime a problem poses a continuous rate of change, we change into this equation. We change into P times e to the RT. So continuous is analogous to a PERT where we have the initial investment times e to the power of rate times time. So in this example, we have the initial population at 300, and then our rate of growth is 21%. And then we're going to see how long it takes. It's 24 hours. So with an hourly rate, I need to put in 24 hours for 1 day. And so with the calculator, I would type in 300 second ln. So that's e to the power of 0.21 times 24. And that's going to be 46,300. Ooh, that's a lot of bacteria. So from the next quiz, it says Einsteinium decays at a daily rate of 0.25%. If there are 45 grams of Einsteinium in rock, how much Einsteinium will there be left after 1100 days? So to solve this problem, we could say, let's see, the amount, which is 4,500 grams, and then we're going to subtract the rate. We're going to subtract the rate of 0.0025, and then we're going to compound that rate at 1100 times. And so when I look at the parentheses, it's the way we think about this. If I take 1 minus 0.0025, I get 9972. So what that means is every day it maintains 99.75% of its amount. So if I multiply that to the 11th power, this is how we can calculate how much is left. So I do 1 minus 0.0025 to the power of 1100. It'll give me 286 grams. Okay. Now let's think of another avenue I could have done here. If I assume that this decays at a continuous rate, let's see what that would look like. So at a continuous rate, that would be the initial amount times e, the power of the rate of negative 0.0025 times 1100 days. And you're going to recognize I get something a little bit larger, but it's really close to the right answer. The only difference is it's compounding